Hi guys, I'm Andrei, and along with my colleague Bero, we are going to talk about the do's and the don'ts when building a Yocto-based distribution. For the past 1 year, we have been working in building a multi-kernel distribution using Yocto/Open Embedded build infrastructure, something that you're probably familiar or at least heard of. During this journey, we have found a set of quirks and perks that we find worth sharing. The presentation is going to have a fairly straightforward structure. We're going to start with setting the scene or giving you a bit of a context, and that is telling you about Oniro project, followed by details on each of these lessons learned that we find worth raising. Great. So what is Oniro project? Oniro is an Eclipse Foundation project focused on the development of an open source operating system for consumer devices, no matter the make, the brand, or the model. Partners can reuse existing primitives, components, software stacks in building their own products. And while doing so, they can take advantage of the processes that the project offers in terms of CI, IP compliance, testing, for an accelerated product delivery. It is an ecosystem that behaves both as an accelerator, but also as a reference implementation for various use cases, aiming high at interoperability, security, privacy, and usability. In terms of the build system, we have chosen Yocto/Open Embedded as the build infrastructure. This is aligned with the industry standard, and it also aggregates of open source projects like Linux, Zephyr, LLVM, to name a few. While building Oniro project, we have found a couple of aspects that we find important. Most of them are things that ended up biting us because of unfortunate decisions, or are just observations that are worth keeping an eye on when working with this build system. The first do I'm going to talk about is do layers structurally right. In Yocto, we have this concept of layers, and this concept helped a lot the ecosystem by providing at least 3 fundamental features, and that is scalability, flexibility, and composition. Now the thing is, layers are not the answer for any structural need. If you're only concerned about pure grouping, you can use simple directories. If you're not concerned about the composition aspect, most probably you're not in for a new layer. So I'm going to tell you about a decision that we've done at the beginning of the project and was proven to be a mistake. We have decided to create a new layer called Meta Oniro Staging that was meant to hold all the changes while we undergo the upstreaming process and the upstream undergoes the reviewing process. So in this way, while this happens, we can have a place for this metadata to reside and our build system be able to take advantage of them. The problem is that by definition, these changes were meant for upstream. So by definition, our local changes were meant to be removed. And hence, our local layer was meant to be empty at some point. Now, the build system has a mechanism to flag if it detects an empty layer. This is because it wants to warn the user in case of a misconfiguration and metadata being ignored in a specific layer. So we ended up basically throwing needless and confusing warnings to our users just because we've done a mistake in our structural decision. Do mind layer depends. Now each layer has a layer configuration file called layer.conf, and this file defines various variables in the scope of the layer. For example, bb files, which is the bb and bb append that this layer provides. The bb file underscore collections, which is the collection ID to be associated with this layer. For example, as well, bb file underscore pattern, which is the mapping between the collection and the entries in BB files. It also defines a variable called layer depends, which is the dependency between a collection and one or multiple other collections. For example, the collection Oniro-staging in this case depends on the collection called core. The thing is, the layer.conf file is usually reused or copied from existing layers. So we ended up in various situations with a layer depends definition that was not relevant for the layer at hand. So make sure if you copy that from an existing layer to update it based on the needs of the layer. And even if you have a dependency on the layer, take into consideration of using the dynamic layers mechanism. That is defined by the variable called bbfiles_dynamic, and it works as it follows. The build system will take into consideration the bb and bb appends file in the path, for example, dynamic layers/meta networking only if the collection networking-layer is accessible by the build system. Otherwise, it will ignore them. In this way, you can have BB appends that are only relevant for a specific layer, hence for a specific collection. You can see the full implementation in cookerdata.py in the Bitbake repository. Do write no surprises layers. Have a mindset that in an ideal world, all the layers could reside in your bblayers.conf. In other words, if I'm importing your layer in my build configuration, I shouldn't end up with as-state invalidations. And I'm taking now an example from psplash bb append that is provided by the Meta Raspberry Pi Yocto BSP layer. This bb append defines the splash image for the Raspberry Pi machines. Now it does that by using an override called RPI. And in this way, if you keep building for QEMU x86-64, for example, you're not going to be enforced with the splash that is Raspberry Pi specific and hence not relevant for your machine. If you have a layer that provides a BusyBox BB append that in turn provides a specific configuration, this shouldn't apply by default without using any kind of flexibility. For example, you can use distro features. In general, be a nice citizen. Try to make your layer as flexible as possible so that it can be used in as many use cases as possible. This is a simple one. Do use layers index. I was surprised that in some discussions I had, not everyone knew about the layer index. You can find this database of layers, machines, classes, distros, and so on as part of the layers.openembedded.org webpage. So in other words, if you are to integrate a new recipe, define a new machine configuration for your own use case and so on, do check it first against the layer index. You might either avoid duplicated work or find references of existing work that could lead you to a good starting point. Do understand and evaluate mixing layers. The mixing layer concept is a fairly new concept in Yocto, and it arose after the project started to provide LTS releases. There are very slim layers that provide specific support on top of a specific LTS release. And it provides a solution to the problem where community wants changes that are possibly invasive in an LTS release by separating them into a different layer. And I'm giving here an example from the layer index, Meta Python Mixing, which is a mixing layer on top of Meta Python for additional modules, versions or various other backporting functionality that is meant to work on top of the Dunfell LTS release. For more information about mixing layer, you can visit the webpage that I'm providing at the top of this slide. Do run Yocto Check Layer often, and the reason here is quite trivial. Maintaining a healthy layer, and there is already tooling in place. There is a script called Yocto Check Layer in the scripts subdirectory of the OE core, and that's going to check your layer against the assumptions or against some of the assumptions of the ecosystem. It's also one of the prerequisites for the Yocto compatible program. So if you ever want to go through that program or you want to maintain that compatible status, you want to run that script often, or even better, run it through your CI pipelines. Nevertheless, taking advantage of this tooling is going to maintain a healthy layer, and that is something you want to strive, because it's going to give you an easier route of maintainership on your software stack. And with that being said, I'm going to pass it on to my colleague, Barrow. I just realized that I've said quite a couple of do's and very few don'ts, or most of them were undercover don'ts. But I'm sure that Barrow is going to fix that balance for me. Thank you.
Thank you, Andrei. I did notice you talked only about the do's and not the don'ts, and I totally understand you're just being modest and you don't want to talk about your own work. I am going to talk about some don'ts and rephrase some things that could be either into don'ts. No, they are not actually Andrei's work. They are everyone's. But let me start out with one we didn't actually run into while building Oniro. Even though it's possibly a mistake I made, but it's a mistake I made while signing up for FOSDEM. Don't. Regardless of what you're doing, don't replace those great Linux, Zephyr, LightOS, FreeRTOS and other kernels with DOS. Not even if you've been misled by the title of this talk being about DOS and don'ts. But let's get serious now. My first real point is, don't fork and forget. All those changes going on in upstream projects are happening for a good reason. While it may be a bit of extra work right now, for example, rebasing your patches so they can apply it upstream, you don't want to be using something based on Dunfell 2 years from now. You also don't want to start over when building a new version by having to rebase on something that is totally incompatible with what you've done before in 2 years. So let's avoid getting into the same mess that some SoC makers are still making with the kernel versions. I'm sure everyone who is interested in building a distribution has seen stuff like, you can only use this device with kernel 4.10, and you need our 15 million 9 patch set. And we don't care, it will be 4.10 forever, even when kernel 5.17 has been released. Don't do that. Keep an eye on upstream, and make sure your modifications can be used with newer versions. Related to this, you may run into a situation where you want to pull in a package from a newer Yocto version, or even the Git master branch. For example, we wanted to build on Dunfell in order to make sure we get security fixes from upstream for a long time, but we wanted to have current toolchains. So we imported the toolchain packages from master and made our modifications on top of that. While it worked pretty well, that wasn't the best idea. Now that we are moving to Kirkstone, we have to sort out what parts of our recipe were coming in from the backport and what local modifications need to sit on top. That's extra work we shouldn't have to do. We should instead have pulled in the backported packages as is, and added a separate BB append file with our local modifications. That way, we would have moved to the newer codebase without having to modify our local changes, except possibly having to rebase them, because the newer package from Kirkstone might be even newer than what we pulled in through the backport. So, don't mix backports with other modifications, and obviously this applies not only to toolchains. Do this for every package you backport. Another important point, probably one you know about because you're attending FOSDEM, don't hide behind the BSD and Apache licenses. Open your code. While many projects, including Oniro, theoretically allow you to fork the code and not release your modifications, we strongly encourage you to release your source just like you would when dealing with GPL licensed software. It helps everyone, It helps your customers, who get to make further modifications if they want to. It helps you and your customers and users, who get to adapt the solution to their unique personal needs if they have the skills. And in the end, it also helps you. You won't have to rewrite your patches every time you pull in something from Upstream. Also, even if you've already released a product without releasing the source, it's never too late to do that. It will still help people, and it might even still help you. So even if you have some old project sitting around that you no longer care about, release the code. And ideally, you want to go further than even just releasing the code on your own side. Upstream changes that are generally useful, or even ones that just aren't harmful to most others, for example, solving some niche problem you expect nobody else to run into. Even if it takes some extra time initially, you may have to forward port your modifications to work on master, even if you originally modified an LTS release, it more than pays off when you update, and you get some free goodwill and advertising out of it too. And whenever possible, don't work behind closed doors. When you have rather big modifications, like for example introducing support for another previously unsupported RTOS kernel, challenge your solutions with the Upstream project before starting to implement them. We have completely changed our approach several times after combining efforts and expertise with Upstream. Related to this, keep an eye on Upstream communications channels. Mailing lists are a good start, regular meetings are great, and so is attending events like FOSDEM. This allows you to avoid being surprised by changes that may have a big effect on what you are doing, and you get a voice by being able to object to something or improve someone else's idea before it's too late because that idea has landed ages ago. And of course, the Upstream bug tracker or master branch may already have a fix for the problem you are trying to solve. So that's the key do's, even if not does, and don'ts we've gathered from a year of working on Oniro. If you have any questions or want to share your own ideas, or ideally you want to volunteer to help our project, Andrei and I will be taking questions now, and we might even be able to answer. Or you can find us at the FOSDEM Oniro booth while FOSDEM is on, or on the communication channels listed on our website anytime after. Thank you for your attention. And it looks like we are live. So do we have any questions?
Hi everyone. Let's see. Not yet. Not yet at least. Do we have a moderator? Is there anyone handling this session? Not sure. Okay, so I can ask a question to Bero. How do you find, because I know you've been, how long have you, first of all, how long have you been working with Yocto as a build infrastructure / distro creator?
Not actually that long, because my background is primarily in desktops and then for a while in Android. So obviously I've been using it on and off for quite a while, working with OpenWRT and the likes, but yeah, it has never been my primary thing to do. So I've looked at it for the first time maybe 10 years ago, but I've only really started getting into it when I joined Oniro. And how about you?
Well, I've been in the ecosystem, I guess, for at least 10 years now. But yeah, I guess my professional path was always side along with Yocto. So I had it like a continuous thread along the way. So my follow-up question was, how do you find it? Okay, well, we have a question now. How do you manage downstream projects from Oniro? Is there a clear guidance how to use the project as a downstream? So generally, we fit into the same architecture, the same setup as Yocto / Open Embedded, right? So you can always have an extra layer that brings your own component, brings your own distros and so on, and you can basically have a distro, for example, that is on top of the Oniro existing distro and build on top. That's roughly what a downstream setup is currently envisioned as.
Yeah, and of course, the chances are, if you want to use it as downstream, you want to join our communications channels so you can see what we're doing and discuss your changes with us. Don't be scared. We don't bite, not even my dogs. And of course, we welcome both open source projects and corporate users as downstream projects.
Now, we have plans to extend that as well through providing SDKs and ESDKs and whatnot. So that is a topic that we currently shaping. The project it's still at the stage where a lot of aspects of it are still being defined as we speak. Things like release cycle, for example, we just drafted a couple of weeks / months ago. So a lot of things we are still in the process of defining as of now. So if you're interested in getting your voice heard, we are willing to hear from you. Any other question? Let me check the distribution channel. Oh, now I hear myself. So confusing when you get into the channel and you hear yourself with a feedback.
Yeah.
In a couple of seconds. I'm like, what is happening? Cool. Okay, let's give people a couple of more seconds. I think we still have at least 1 minute of Q&A live.
And of course, after that minute, you can still find us at the Oniro stand or on Mattermost if you have any questions that are not ready yet, or if you're watching the talk on a recording.
So I think there is one brewing as we speak. Fred is typing, so let's wait for that one, and probably we'll have to wrap. Is there a method for so in the build process, is there a method of inserting hardware to visualize errors when it breaks? Does this tie into? I think I'm not sure if I'm interpreting this right. We're only having a couple of seconds, so pop to our talk channel for